Welcome to our 3DS presentation on circular innovation. As we all know, climate change is one of the greatest challenges that faces humanity. Very soon, issues ranging from resource scarcity and food production to biodiversity will no longer be problems of tomorrow, but problems of today. This is why, as we move forward in the 21st century, the need for innovative and sustainable solutions is greater than ever. The time has come to act. For instance, in Europe, the average car sits unused 92% of the time, and in 2020, only 14% of worldwide plastic was recycled. One solution is to adopt a circular approach to product development. Indeed, beyond the benefits to the planet, by adopting the principles of the circular economy, Europe can create a net benefit of 1.8 trillion euros by 2030. And regulation is reflecting this need by holding companies accountable for their waste. Today, I would like to show you how you could become a leader in sustainable innovation by adopting a circular development process and contribute to a brighter future for humanity. How you can inspire young talents to join your teams and create the products of tomorrow, and grow your business in a world which values sustainable production networks. More importantly, I'm here to show you how you can achieve this with a 3D Experience platform, a model-based solution that allows you to create a digital twin for your products from cradle to grave. We will first look at how topology optimization can help you reduce the weight of your machines and use less energy as a consequence. We will also see how you can create high-performance batteries, a key technology for power storage, starting with the design through to production and end of life. Next, we will show you how to deal with material compliance issues as early as possible in the product development, ensuring your products satisfy environmental norms. We will see how to reduce energy waste from buildings, a key challenge to upgrade our infrastructure to the 22nd century. Finally, we will close the circular innovation loop by seeing how you can take ownership of the end of life of your products. I'm Thomas Jansen, here with the industrial equipment team from Dassault Systèmes. We're here to show you how you can meet the challenges of the circular economy with a 3D Experience platform. Augustin, take it away.
The first topic we would like to introduce in the scope of circular innovation is the ability of 3D Experience platform to help you design machines that will produce better and more with less energy. In fact, we know that one of the big challenges we are facing is to make our production more sustainable while keeping same level of performance at the output. And today, we are convinced that the needed energy to run a system of production could be reduced by 20%. So, how can 3D Experience platform help you to do better and more with less? Here is an example. You have here a big rotating machine holding 12 heavy bottle molds. So we decided to redesign the biggest part of this assembly to remove all unnecessary material and thus reduce energy consumption and the global forces that this big moving mass is applying to the whole structure. To make this part lighter, we first define what are the interfaces of the part. Then we define the loading conditions, that is to say, the maximum pressures and forces that this part is going to withstand. Then we just have to launch the optimization. And this will define the exact location where the material is strictly necessary to handle the loading conditions. And in this case, the calculated weight reduction is about 40%. Once a new design has been generated, it is very easy to validate the structural integrity of this concept on different load cases. In fact, the structural simulation tools are accessible through the same platform. In this case, we wanted to rebuild the shape of the part according to its manufacturing process. And here again, it is just a matter of few minutes to get a smooth surface following generated shapes of the concept. So, now we know how easy is this lightweighting process. Why not involving other parts in the loop? Now the holded part is much lighter, we should be able to downsize the supporting parts. And so again, we define all the functional surfaces, the loading conditions, and then CATIA will generate an optimized, light and strong support. And again, this can be validated very easily right after on all the given load cases. So from the weight reduction of a single part, there is a positive chain reaction to the other parts of the machine, and this is how you can save a lot of energy. So in this example, we saw a real opportunity to lightweight the moving parts of a machine, and that is considerably decreasing the needs in terms of energy. But there is some other very important benefits. As soon as the machine is lighter, the components creating the movement can be downsized too. In fact, they no longer have to rotate or translate any useless mass, so the power and price of the motor can be reviewed downward. Meanwhile, the structural integrity of the machine is guaranteed, thanks to the powerful simulation, and then this is why the lifetime of the part is also extended and will increase the customer satisfaction. So with 3D Experience Platform, you can enter in this circular innovation loop where you start redesigning a single part of your machine, which is leading to multiple other opportunities to do better with less.
So now let's talk about batteries. Today, batteries are key to tackle challenges of power storage and bring people most of their daily life experiences. They power small and large-sized devices. They can be exposed to very difficult and dangerous conditions. And the need for batteries with higher capacity is very strong. However, creating efficient and clean batteries forces manufacturers to find difficult trade-offs between capacity, safety, power, all while keeping up with dynamic demand, innovative application, and global regulation. They have to address these challenges all along the value chain of battery creation, from material scientists to cell and pack engineers to system integrators. They all contribute to create safe, high-performing, and sustainable batteries. The high-performance battery solution from Dassault Systèmes uniquely connects the entire battery creation network for more flexibility and efficiency in creating competitive batteries for a dynamic demand. So let's see how our solution provides value for the whole battery value chain. First, we start with material research. We look for innovative formulation to reduce the limitation of various raw materials and increase, in the same time, the battery performances. Thanks to the 3D Experience platform, we can perform molecular analysis and material simulation. In this example, we want to enhance electrolytic conductivity while reducing flash point temperature of the substance. We make trade-offs, looking for the best compromise between mechanical, electrical, and thermal properties. To do so, we can combine various raw material and chemical elements to create the most appropriate substance. Molecular structure, viscosity, and number of additive elements are taken into account. Then we run a number of configuration scenarios to test the electric conductivity. The tests run in batch mode on multiple CPUs, and results are presented with molecular trajectories animation and all calculated chemical properties. Then we make a behavior model of our electrolytic prototype out of this trade-off. We can reuse this model in our system simulation tool to evaluate the battery cell behavior. Thermal power and generation are simulated for both charge and discharge. Our solution is based on Modelica language and allows us to perform multi-physics simulation scenario according to the desired usage. From a higher point of view, we can consider the whole battery pack and each module connection, and we can run multiple simulation use cases to estimate delivered voltages and thermal dissipation. Those results can serve as boundary conditions for finite element analysis about the battery pack using our process composer application. Our unmatched portfolio of multi-physics simulation tools allow engineers to evaluate the battery response to various mechanical loads, conditions, to make thermal runaway prediction, analyze various cell placement strategies, and design cooling challenge in the battery module to avoid overheating. Design exploration makes it possible to study hundreds of alternatives and select the top performing solution best matching our sustainable power, safety, and cost expectation. As mentioned previously, our application brings value for the entire battery creation network. This means the manufacturing process reuses the engineering product of the battery pack and integrate every design update. We can simulate battery cell assembly operation with regard to the process planning and combine it with our robotic programming application. Eventually, as per Dassault Systèmes sustainability vision, we want to promote circular innovation for product end of life and recycling. Thus, our manufacturing solution can also be used to investigate the battery pack dismantling process. The aim is to be able to recover raw materials and not waste them to landfill, which is a very sensitive topic at the moment. As you can see, Dassault Systèmes offers a unique solution addressing the full battery life cycle from design engineering to manufacturing and dismantling process. We are a science-based company which contributes to material innovation and research. We want to promote circular innovation by reducing cell scrap in the manufacturing process and contribute to battery recycling. So thank you for watching. I hope you enjoy, and I hand over to my colleagues. Simon.
Thank you, Vincent, for your explanation. Now, with me, in this part of circular innovation demonstration, we are going to talk about materials compliance management. It's really a key topic because, as you know, industrial manufacturers have to face more and more regulation to limit and control dangerous substances used in the components, especially in the electronic and electrical equipment. Because of that, manufacturers of machines need to have a complete solution to collect and centralize all information regarding substances coming from suppliers, perform an assessment phase of materials compliance as early as possible in the product development, and provide the compliance information into a public database in order to share with industrial actors involved in the recycling processes. Manufacturers must ensure a true and safe circular economy. At any time, they need to be able to confirm the materials compliance used in the machine. In this sense, with the 3D Experience platform, directly in the web interface, we are able to collect and analyze all regulations that we need to respect to develop a new machine and so get authorization to sell it on the market. Regulation coming from different countries and dealing with different topics like REACH regulation, which is a regulation to limit chemical substances in the components. We can manage an overview of product compliance status where we have indicators in function of the regulations that we have to respect. In this monitoring page, the compliance managers can make the right decision quickly to fix the compliance issue early in the product development. On the filler machine, for instance, directly on the engineering structure, we can collect and centralize all materials information coming from the suppliers. For each component used in the filler machine, we have the materials definition with the substances compositions. If we focus on the electrical motor, all information are available in the platform to ensure a strong link with the suppliers. We can visualize also the compliance definition of this equipment, especially the list of regulations impacted by the use of this kind of motor in the machine. So, for each regulation, an automatic calculation has been done based on the materials information defined in the engineering structure in order to know if we are compliant or not with these motors. The 3D Experience platform improves the share of information with the external actors involved in the circular economy. Indeed, at any time, we are able to generate, by selecting the regulations that we need to take into account, different compliance reports, where the dangerous substances are identified with their location in the machine and their materials. This report could be communicated to downstream suppliers and to any end consumers on demand. In this last step, directly from the platform, we have a connected interface with the official public database in order to provide and share all compliance information defined in the 3D Experience platform to any consumers. We are able to create and submit compliance reports to be saved in the database. And in the official database, we can find all the information corresponding to the compliance declaration coming from the 3D Experience platform. Because we propose a complete solution to manage materials compliance, industrial manufacturers can collect and check all compliance information on a product early in the development process to ensure a true and safe circular economy for involved consumers. Thank you for your attention. Now, I let the lead to my colleague, Augustin, to talk about reduce energy waste in the context of HVAC system in buildings.
So now we are going to talk about the way 3D Experience platform can help you reduce energy waste for building equipment. Living environments are facing key challenges around circular innovation and energy efficiency. At the same time, humans spend roughly 90% of their time indoors, according to research. So indoor environmental quality is key to maximize health, well-being and comfort. However, it should not be at the cost of our planet and its resources. So reducing energy waste is also critical. We can create healthy indoors and reduce our environmental footprint at the same time by using Simulia solution, which enables you to design high efficiency and health HVAC systems tackling thermal comfort, indoor air quality and noise control. Dassault Systèmes provides solutions for the various stages in life cycle of HVAC system, component design, component integration and system customization. With our solution integrated to the 3D Experience platform, you can collaborate, democratize simulation, track and verify requirements of your HVAC to improve energy efficiency and promote innovation and quality. HVAC in buildings are noisy. With best-in-class simulation-based solution for acoustics, you can design quieter equipment. Our solution provides the identification of noise-generating regions predicted from accurate transient airflow. Indoor air quality affects general health and productivity. Our solutions accurately capture the transport of pathogens and harmful gases. This will allow you to include interior air quality as an HVAC requirement, down to the simulated performance and lifetime of particle filters, and balanced this again thermal comfort and energy efficiency. Efficiently maintaining thermal comfort is a challenge. Our simulation solutions allow you to replicate real-world conditions and human physiology inside the building. This includes weather conditions or other realistic heat sources in the environment. We can then assess the impact of insulation material and find energy loss paths by accurately capturing transient flow and temperature, thereby optimizing HVAC vent position and shapes. Performance gains are achieved by customizing an entire HVAC for a specific building. You can leverage the 3D Experience platform and multi-scale simulation to maximize human comfort and improve energy efficiency. Review simulation results online using lightweighting rendering and facilitate collaboration. Integrate 3D simulation results into 1D diamolar system representation for cost-effective prediction and full building optimization. This enables you to verify your SEER number and certify against the Energy Star label to minimize operating costs. This is how 3D Experience helps you support HVAC equipment and green building certification. With Dassault Systèmes, design robust, high performance and energy efficient HVAC while ensuring thermal comfort, indoor air quality, and low noise level.
The end of life of our products will become an increasingly important part of operations as society transitions towards a circular economy. Indeed, regulation is shifting responsibility towards machine builders to deal with the products they sell once they are no longer usable. It will become necessary to consider the end of life as early on as in the design phase to understand which parts could be refurbished and reused and which materials could be recycled. This is what we call a design for dismantling. I'd like to show you how with a 3D Experience platform you can design products that are easily dismantled, analyze the dismantling process of your machine, and streamline your end-of-life services, all in a single environment. So this is a machine we are designing. We would like to understand how to dismantle it. It has different modules that do different things, but today we'll just be focusing on one of these. So we're currently using the 3D Experience platform. It is an environment which allows us to access different applications all in one space. No need for exporting and importing data. In the same environment, we can access our engineering data. These are our 3D parts and assemblies that we can use to create service and process structures. Our service data, or service bill of materials, defines which parts are to be considered for our dismantling process. And the process allows us to define and visualize the steps of the dismantling process while considering the time and resources necessary to do so. So we have created a virtual twin of our machine, which allows us to keep track of the state of our machine during its lifetime. This approach means that our process definition is linked to our engineering data. Changes in design are easily propagated to your dismantling process. All right, so we've set up a dismantling process. We know which parts are to be dismantled, how long it will take, and the necessary steps. But how can we be sure that what we have defined above is physically possible? This is where assembly evaluation comes in. So here, we are able to visualize the steps that we have defined previously and define paths that parts should follow. Here, we focused in on a specific part of our machine. So thanks to our analysis, we find a clash. The designers chose to use snap fits, which aren't easily disassembled. So a redesign is necessary. This is easy thanks to the 3D Experience platform. All we need to do is open the data in the appropriate application. This allows us to have a quick access to the tools we need to do the design without exporting or importing data in a separate software. So we've decided to use bolts to fix these parts together instead of a snap fit. And using our PLM solutions, the changes are propagated to the process structure. These are the steps that we've defined previously. And we can easily run a simulation with the new design. We thankfully find no clash with the new design. This means we can dismantle this part without damaging components, and they can be refurbished, reused, or recycled. So we've completed our design phase, but what about the end of life? How can we help our workers dismantle the machine in a safe and effective manner? To do this, we can generate work instructions to for the processes that we've defined previously. So we can create process catalogs and 3D views of the process steps. And this can accelerate and streamline your end-of-life services by allowing your workers to visualize the steps of the dismantling process. And remember, these instructions are part of the virtual twin. They are linked to your engineering data, which makes it easy to update your instructions as your product evolves. This means that your design, production, and service engineers all work on a common database. To recap, with the 3D Experience platform, you can ensure your products are future-proof by considering their end of life during the design phase. We've seen how our solutions can help you design products that are easily dismantled. You can analyze the dismantling process of your product in terms of feasibility and time, and you can streamline your end-of-life services by creating catalogs and 3D work instructions. And finally, you can connect your teams at different levels of your organization. Okay, so we've seen how with the 3D Experience platform, we can tackle the different challenges related to the circular economy. Our model-based approach allows you to extend your scope of work beyond the design phase by considering the end of life of your products. So you can reduce your energy consumption by reducing the mass of your machines using topology optimization. You can create innovative battery technology and anticipate their recycling. You can make sure your materials meet environmental norms. You can upgrade your infrastructure to reduce energy waste. And finally, you can close the circular innovation loop by designing products that are easy to dismantle and take ownership of the end of life of your product. All of this in a single environment, the 3D Experience platform. We were the industrial equipment team from Dassault Systèmes. Thank you for your attention.